Stephan Herminghaus, Professor of Physics at the University of Göttingen and the Director at the Max Planck for Dynamics and Synchronization. Well, we have microfluidic projects in quite a number of different settings. One of the most future-oriented one is in synthetic biology, where we study possibilities to understand how life came about on this planet. And as part of a larger consortium of 5 Max Planck institutes, which is called under the headline Max in Bio, so we do try synthetic biology in the Max Planck Society. This is not easy to answer because I have to decide. Should I, if I tell the truth, it takes another 20 minutes.
No, briefly.
I thought it was fun. Well, how did we start with? Okay. Originally we started wetting phenomena. And then we started wetting phenomena, of course, initially on flat substrates. And then after some time, it became clear that wetting of ideal substrates would become textbook knowledge. And then you have to keep the grad students busy and come up with new questions. And so we decided to investigate the wetting of more complex structures. And so it was obvious to start with grooves, and then we had open microfluidics, and so we started, well, this is maybe a nice side project. We started to do open microfluidics, and then we went into more complex things, did two-phase microfluidics, then we had droplet-based microfluidics, and so we got into it. The last scientific result I presented in a conference was a work where, having realized that that no surface actually is ideal, but all surfaces are rough, but there is no predictive theory on how wetting works on a randomly rough surface. We did this, and we got some results, so we can predict wetting properties of a randomly rough surface, and this is what I presented last, and what I also will present on Wednesday. The result I'm most proud of is a very recent result I didn't even publish.
Okay,
is that I have to make one sentence before. This is a little complicated, but since about half a century, people are looking for an analog. I mean, you have in statistical physics, in equilibrium statistical physics, you have the free energy, and the minimum of the free energy tells you where the system goes. For half a century, people are looking for the analogous thing in non-equilibrium systems. And everybody, Prigogine got a Nobel Prize about it. About the same time, it was proved that he was wrong. And since then, nobody touched it. And now we found how it works. But we have not published it yet. But this is probably the result I'm the most proud of. The current challenge the current challenge, I think, is best exemplified with one very recent project we acquired now funding for, is an application of active fluids, which is traffic flow.
Okay.
Traffic is an active fluid, and if you look at the traffic infarction you have in each city every day, you see it's a really, really very pressing problem, and mobility is not solved for the years to come, and we are going to reinvent a public transportation system which hopefully will solve that project. Actually, the breakthroughs I want to see are not really in my field. The breakthrough I want to see is that mankind or humankind has finally come to a stage where there is hope that we can manage to live on this planet in a sustainable way. Actually, the project which appeals to me Most is what I just told you. This is the one I'm most proud of, and now I want to apply this to genetics and system biology and pattern formation and all that. This is probably the most significant thing for the 5 years to come, something like that. The most memorable, if I say my field is physics, I would say it's the discovery of gravitational waves. The advice would be, don't look too narrow-sightedly on research. Also be very keen in looking at industry jobs, because there's a lot of interesting stuff to do there, and there are only very few jobs in research. Oh, there is, for instance, of course, here the ESPCI and the new Göttingen Institute is one of the very famous and very important soft matter institutes. Then there is the University of Twente, in particular the group of Elveflow, whom we have a joint appointment with. There are very, very interesting institutes coming up now in Bangalore, India. The NCBS, National Center of Biological Sciences, which I have highest estimation of. Then there is, of course, Harvard University does a lot, New York soft matter group, like around Paul Chaikin and Dave Pine. I mean, there are quite a number of places. Yes, probably too many to. Yes. My feeling is that in microfluidics, the most promising idea is what Whitesides told us this morning, like paper microfluidics. I think this is really a cool idea, and there's a lot to still invent there.